Hello guys! Today's video is about saving a pandas data frame to file. We'll start from the typical use cases that you might face when working with data frames. And in order to prove our recommendations, you may review these benchmarks and also a benchmark that we make in this notebook below. So first, if you have to save your data frame to a file in order to reopen it later in another notebook session, the best format for you is feather. If you are used to pickle, it's also okay. If you want to save a data frame in a smallest possible file size, parquet is awesome choice for you, and also compressed pickle is good. But you may notice that the compressed pickle format is pretty slow in terms of saving. It loads pretty fast, but it takes about 5-6 times more time to save the data frame in comparison to parquet. If you have to save a very big data frame, let's say containing tens of millions of rows or even more, then HDF is the best choice for you. If you want to be able to read the data on another platform, it means not Python, and if that platform doesn't support other formats, then CSV and CSV compressed is a good choice for you. But before using CSV, please check if your target platform supports, for example, parquet, because it may support. If you want to be able to review the data frame with your eyes, or use Excel or Google Sheets to open it, or be able to make a Git diff, then CSV is the best choice because it's textual format while the other formats are binary. And finally, if you want to save a data frame that takes almost all the memory on your computer, it means operational memory, then CSV is also the best choice. We'll speak about this use case a bit later. And here is a benchmark for you that was prepared by Ilya Zaitsev, and here is a link to his publication, which shows the time for saving and loading of data frames in different formats and the disk space they take. You may notice that parquet is pretty good both in terms of saving and loading time and in terms of disk space. Feather is also good in terms of time. In this benchmark, we see that parquet is faster in terms of loading, but in our benchmark below, the picture is a bit different. This may be caused by the different configuration of the server. So like what CPU you have, what hard drives or SSD you have, these factors influence the performance of the formats. You may also notice that CSV is the worst in terms of time, in terms of saving loading speed, and HDF is the one that takes the greatest disk space. But if your data frame becomes bigger, the benefits from HDF become more obvious and the overhead it has becomes less significant. Here are the usage examples of different formats. In order to test them, we will use the Kaggle train dataset. It is pretty small, it contains about 900 rows. And in order to make our benchmark better, we'll do a couple of tricks. First, we'll repeat the original data multiple times in order to get about 9 million rows. But in this case, we'll have all the data repeated multiple times and we'll get an incredible performance for the algorithms that make data compression. In real life, in data frames, we have some data repeated, but also we have some unique data. So in order to balance our data set, we add an UUID to our data. Here is it. And it will be a unique value in each row. Finally, as a result, we have the data set that is about 900 megabytes, which is decent. The methods for saving and loading data from different formats are quite similar. They usually start from to and underscore, and then the format name goes. And as a parameter, you pass the name of the file. As you may see, feather is pretty fast and it takes more than 1 gigabyte. Pickle, almost the same API. You see that it takes a bit more time to save the data and a bit less time to read the data. The numbers may be different on different computers. They won't be different like dramatically, but still they won't be exact. Here is a compressed pickle, and you may notice that it's pretty easy to add a compression to your pickle file. You have to add just an extension, and pandas will understand automatically that you want to have a compressed format. And you may also notice that the compression takes quite a lot of time. It takes about 6 times more than an uncompressed variant. But the disk space is also quite lower. It's about 5 times lower than the original pickle format. And also, the compressed pickle is loaded pretty fast. It takes about twice more time to load the compressed pickle. The CSV takes lots of time for saving and loading, and the same for compressed CSV. Parquet format, really good in many cases, takes a bit more disk space than the compressed pickle, but it's really good in terms of time for saving and loading, and it looks as a really good balanced format. HDF format takes also not very much time for saving and loading, the biggest disk space, and there is one additional parameter you have to pass in HDF, which is the key. This will be the name of your data frame in the target file, and HDF format allows you to save multiple different data frames in a single file, and then you will be able to read them separately. This may allow you to make chunking or partitioning of your data, which is useful in cases you have really big amounts of data. One more notice about the CSV format is that it is a textual one, and all the other formats that we've reviewed are binary. And the fact that CSV is textual means that it doesn't store the information about types in the file. And if, for example, you have a column which is a string one, but it contains only numbers, like numbers converted to strings, and if you save it to CSV and then read the CSV file, if you don't provide the type names explicitly, pandas will read this column as numbers. So this may be an unexpected effect. Please be careful about it. And as I've promised, here is a benchmark of the memory consumption during saving and loading of the data in different formats. You may see that HDF overhead is the biggest, but again, this overhead will be relatively less if you increase the size of the data frame. And CSV is the best one. It is pretty easy to explain. When a computer saves the data to disk in CSV format, it just reads your data row by row, converts it to string, and writes to the file. It all, of course, makes it in an optimized fashion, but still the idea is like this. And it makes pretty the same thing when it reads the data from disk. But if, for example, your computer saves a pickle data frame of about 1 gigabyte, it requires about 1 additional gigabyte to allocate a buffer to write the data before saving to disk, and then it records this buffer to the disk. And if you have a very big data frame that takes, let's say, 70% of your memory, then if you use a pickle format, you will get an out-of-memory exception and your application will crash. But CSV will work in this case, though it will take quite a decent amount of time to make the operation. And at the end of the video, here is a bonus for you, which is about the category column type and its effect on saving and loading data to disk. We'll probably make a separate video about the category column type. Now we'll just focus on its effect on the saving and loading. So our big data frame contains these columns, and you may notice that we have some data columns that have a limited amount of possible values. It's sex, cabin, and embarked columns. Originally, they are stored as strings, but we may use a trick with category column type to optimize these columns. After the conversion, you may see that the head provides exactly the same values for these columns, but if we save the original file, we see that it takes 1.3 gigabytes. And if we save the optimized data frame with columns converted to category, we'll see that it takes less time and the operation is completed a bit faster. With this pretty cool feature of the category column type. And one more notice about this is that you will get the benefit from category column types for all the formats, for all the binary formats, but not for CSV, just because CSV doesn't store the information about types and it doesn't handle categories somehow specifically. That's it for today, guys. If you have any questions or comments, please write them below. I'll provide the link to this notebook in the description to the video. Subscribe to my channel in order not to miss new videos about pandas, machine learning, and data science. And never stop learning. The more time you spend on self-education, the better you are. Bye-bye.